We are required to draw those four graphs on the same system of axes. So what we'll do is to alternate the technique as well, where for instance the first one we'll make use of the table method, meaning we'll draw a table, pick a few x values and then determine the y value for it. So we'll say -3, -2, -1, 0, 1, 2 and 3. So feeding -3 into the x, there we'll get 2 times -3 is -6, -6 minus 3 is -9, the -2 will give us -4, -3 is -7, -1 will give us -2 minus 3 is -5, 0 will just be -3, 1 will give us -1, 2 will give us 1, and 3 will give us 3. So plotting those points on the axis diagram, then at -3 for x we've got -9, so say that's -3, we'll get -9, going across like that and coming down all the way there, we'll get the -9, -2 is -7, which will be about, say, there, then -1 and -5, -1, -5, and then 0 was -3, which means the y-intercept is at -3, which will be about there. Then 1 is -1, 2 is +1. So now we've gone through the x-axis, and then lastly we've got 3 and 3, 3 and 3, and then we can connect those points. Although this is not drawn to scale, you get the idea. If you had a proper axis diagram, obviously it will be a lot easier to get them all in line, but that's it then for that technique. Then we've also got y equals -1/2x plus 2. So for that, let's make use of the double intercept method. We'll say y equals -1/2x plus 2, and we'll say for the x intercept we'll make y equals to 0. So we'll get 0 equals -1/2x plus 2. Take that whole term across to the left hand side, becomes 1/2x is equal to 2, and x is therefore equal to 4 if you multiply right through by 2. And then for the y intercept we'll make x equals to 0, which means that whole term there will just fall away. So it becomes y equals -1/2 times by 0 plus 2, so y is equal to 2. So we've got the y-intercept at 2 and the x-intercept at 4. The x-intercept is at 4 and the y-intercept is at 2, which will be about there. That will be 2, and then we can draw like that as well. Then the other one, y equals 2x plus 2. Let's make use of the gradient intercept method for that. So we start at +2. Start at +2. Then we look at the gradient is 2 over 1. So we'll go 2 up or 2 down all the way to the x-axis. And then since it is a positive gradient, it needs to lie like that once we're done. So we need to then go the 1 either left or right, depending on which direction the graph must lie, since it has to go that way for the graph to be drawn like that. And then the last one, we've got y equals -1/2x minus 3. Let's make use of the gradient intercept method again for it, starting at -3. So it's about there, -3, and then we've got a half, 1 over 2, so we'll go 1 up and 2 across, but it is a minus, so once we're done it has to lie like that. So we'll go 1, 2 across, and then we'll just connect those 2 points as well. Now what you will notice immediately is that the two graphs, the red and the blue one, had the same gradient, so they are parallel, and then the gradients of minus a half every single time, if it was drawn accurately, would have made a 90-degree angle with those two lines. They would be cut perpendicular if the gradient is minus a half, where it was 2 over 1. So the principle behind it is the one gradient is 2 over 1, the other gradient becomes 1 over 2. This one was a plus, this one becomes a minus. So if the sign changes and the two values of the fraction swap places, you would find perpendicular lines, like those two perpendicular to that, and where you find the same gradient, such as that one, and then also obviously that one and that one has got the same gradient of minus a half. You'll see that they are parallel and those two are parallel. So once the gradient is the same, you've got parallel lines with different y-intercepts. If the gradients are the opposite inverses of each other, and you can multiply them to get an answer of minus 1, that is the property. Two gradients being multiplied to give you an answer of minus 1 will then be perpendicular, such as those two that goes there, perpendicular to those other two.